What could be simpler than a pencil? It's actually more complicated than it looks. For one thing, the lead isn't really lead at all. And just getting that so-called lead into the pencil is a lot harder than you might think. To get the lead, which isn't really lead, into the pencil, you have to start with rocks. Lots of rocks. And a huge steel drum. Just under half a ton of these rocks go inside the drum to pound together the ingredients that really make up the lead. This black powder called graphite, and some white powdered clay. Graphite is a type of carbon that happens to be the same colour as lead, which is why it's mistakenly called lead. And the clay is a binding agent that hardens the mix. The more clay, the harder the pencil and the lighter the line. So a scratchy number 2H has more clay in the core than your softer 2B. H stands for hardness and B for blackness. To get this blend perfectly mixed, the mill turns for a full 24 hours, as water is added inside the drum to help mix it even more. The result is thoroughly mixed graphite slurry that's smooth and liquid with the consistency of chocolate syrup. To turn the runny slurry into a dry powder, it's pumped into a series of mesh molds inside a filter press that works like a giant vice to squeeze out the water. After 5 hours, cakes of the new graphite compound pop out of the molds and dry for a full 2 days so that the mix stays consistent when the cakes get ground up in a mill to prepare the compound to be put through an extruder. A little water is added back in, just enough to turn the compound into a heavy paste. Then a powerful electric hammer pounds the paste into a canister. The pounding removes any air bubbles that could cause flaws in the cores. Finally, the mix is ready to be pressed into the lead or core of the pencil. To do that, the canister full of paste is loaded into an extruder that forces the paste through a tiny die to create the pencil cores. The cores look ready to write, but they're not. Any pressure on them would cause them to crumble. They won't firm up until they're fired on a bed of heat-resistant gravel inside a giant kiln. The intense heat activates the clay in the mix, which hardens the cores and binds the clay and graphite together. Now the cores are finally ready to go into the pencils. To make the wooden parts of the pencils, thin blocks of cedar wood feed into a groover. Cedar is the wood of choice for pencils because it has a strong, straight grain that won't splinter. A cutting blade like this rotates inside the machine to cut 8 grooves into each block for the graphite cores. Then it's over to a machine called the lead layer that assembles 8 pencils at a time in 3 quick steps. First, a dispenser fills all 8 grooves in one board with glue. This is to hold the cores in place once they're inside the pencil. At the same time, the cores queue up in the slats of a rotating drum. The drum drops 1 core onto each groove, creating the bottom half of the 8 pencils. Then, to complete the pencils, a rotating block adds another grooved board over the top to make a lead sandwich. That's how the lead gets into the pencil, 8 pencils at a time. To cut apart the individual pencils, the blocks travel through a shaper that cuts them out and gives them their familiar hexagon shape. The flattened sides were invented to keep the pencil from rolling off the desk. Then it's time for a coat of yellow paint, which has to be non-toxic in case the pencil gets chewed. But why yellow? It turns out that pencil makers started using bright yellow in the 1890s because it was a colour that had long been associated with royalty. Yellow was once a scarce pigment and an expensive colour to make, and so they thought a yellow pencil meant a quality pencil. Now yellow is just tradition, especially in the United States. After the paint dries, a heated dye stamps on the labelling, business logo or other lettering. Now for the eraser. The familiar pink rubber nubs line up in a tipper machine and wait while the little metal fastener called a ferrule goes on first. Then a small ram pushes in the eraser and two metal probes crimp the ferrule around the eraser to hold it in place. The finished pencils roll out of the machine and into the boxer. And the last step? A pencil sharpener to sharpen the cores. Because if the lead stayed inside the pencil rather than on the paper, it really wouldn't be much